Hello and welcome back. So I've made a lot of progress on converting the MakeHuman plugin, which is free and open source, from Blender to Godot4. And as you can see, the skeleton now resizes with the shape keys. And the animations from mixamo.com still work as well. So you can change the age and gender and see that it's still working. And I'm really happy with this. I still need to add the clothing and hair, but I'll probably start working on that in a couple weeks. But if anyone else wanted to try to figure it out, that would be really cool. So in the meantime, you can download the source code from for this project from the link in the description. And now I'll show you how I got this to work. Last time, I regenerated the human mesh with all of the shape keys and the proper shading for each one, and attached it to the default MakeHuman skeleton. So now it can be animated. But of course the blend shapes are still distorted by the skeleton. So this time I need to build the skeleton from the positions of the blend shapes. So first I'll go to my Blender config file in scripts, add-ons, MPFB, data, rigs, standard, and here we have the rig.mixamo.json. So this has the default position and the calculated position with the parent bone and rotation all in the config file, and there's a bunch of other settings that I don't really know what they do, but I'll copy this JSON into the original project, into the humanizer Godot project. Now I want to read the JSON file, so I looked up how to show content of a JSON file in Godot4, and you open the file with file access and then use JSON parse string to turn it into a dictionary. So I'll attach a built-in script to my skeleton builder, and I'll make a new function to read JSON from a file. And we don't want to print the dictionary, we want to return it. And get rid of the file path. So now we can read the mixamo configuration, and I'll make a new variable for that. So we'll set it there and just print out the dictionary for now. So now if I run this, you can see that all of the data from the Mixamo rig has been printed in the output. So all this information So the bones are under the bones index. We also have a couple other indexes in here with a single value. So I'm not sure. The scale factor is probably important, but pretty much we'll be iterating over the bones. So I'll print mixamo config.bones. You can use the Lua syntax so it looks like they're objects, which I think is just easier to read. And I want to update this in the editor since you can't see the skeleton when you play it, and I'll be working with building that. So I'll make it a tool, and I'll add the update, refresh variable of type boolean equals false, and then override the set function, and I'll call the update function from here. You don't actually set the refresh equal to the value, so it stays false and you can toggle it. And then I'll add the update function, and here I want to print the config.bones. So I still want to load the config on ready because we don't want to do that every time it updates. And I'll reload the scene. So now this needs to be an export variable on the refresh toggle. So now it's in the editor and I can toggle the refresh to print out the JSON. And now to get each individual bone, I'll have to iterate over all of the elements of the bones dictionary. Now instead of printing the JSON, I can iterate over the indexes in the mixamo config.bones and print the bone name. So now we have the fingers and arm, foot, head. So we have all the bone names, which correspond to the index in the dictionary. Then I'll start with getting the default position. So I'll need to get the bone data. So I'll set the bone data variable equal to mixamo config.bones at the bone name, and print that. So now we have each bone with all of its corresponding data. And I'll start with the default position. So I'll get the head.default position value. And set that. So now we have each bone and the default position of the start of the bone. There's also a foot or tail for each entry with a default position, but since Godot only has the start position, I'll just use the head entry. Now I want to add a red dot for each bone, so it'll be easier to visualize where they will be before I start building the skeleton. So I'll delete the other two meshes and not delete the animation tracks. Then I'll add a new node 3D to hold the red dots. Now in the vertex finder, I already have a red sphere, which is a normal CSG mesh 3D set to the sphere type. So I'll right click and save branch as scene to make a new scene there, and you can reset the transform. And now in the skeleton builder, I'll make a new variable equals preload the red dot scene. And for each bone, I'll want to make an instance of the red dot. Instantiate, and I'll want to set the red dot position equal to the default position, and then I'll add it to the red dots node as a child. So now if I refresh the scene, it says non-existent function instantiate on base null, and that's because I added this variable, so I just need to reload the scene. And now if I refresh, it says invalid set index position on CSG mesh with a value of type array. So you can see in the JSON with the brackets that this is an array data type, and we need to convert it into a vector3 so we can set it to the position. So I'll make a new function to convert from array to vector3, which will take the array as a parameter, and I'll make a new vector3 variable equal to vector3, and you'll set the x, y, and z, which is array 0, array at 1, and array at 2, and return the vector3. So now I'll set the default position equal to array to vector3 of the default position from the JSON. So now if I update, it generates a bunch of dots in a T-pose, and it's facing downwards because I think the Y and Z planes are flipped between Godot and Blender, potentially. But you can see there's a bunch for the finger joints. That's why it looks like he's wearing gloves. But that does work, at least. So now I need to calculate the actual position based on the strategy and vertex indices, or there's also the cube strategy, which will have a cube name instead. but I'll start with the mean strategy since you just get the position of the two vertices and divide by 2. So I'll go ahead and get rid of the default position. And now for each bone, I need to check if the bone data.head.strategy equals mean. And I'll do another check if the strategy equals cube. Now I need to get the position of the vertex from the mesh, so I'll use mesh.getSurfaceArrays. And this is an onReady variable since you have to wait for the human to load before you can get the arrays. This just gets all of the data that the mesh is built from. And I need to change the node name. So this model only has one surface material. You can see in the material override, but there could be more than one here. So you'll need to specify. And then I need to save that and reload the skeleton builder so that this onReady triggers and we get the mesh arrays. Now I need to get the indexes for the vertices. So first I'll make a new variable for the bone position equals vector3.0. Then for index in bone data.head.vertex indices, I'll add the position to the calculated bone position, and I need to get the mesh arrays at the mesh.vertex, which is the 0 index, and then get the ith position, and then I'll divide by 2. And of course I want to set the red dot at the position, so I'll move this and change the variable name. So now if I refresh the scene, you can see that the red dots have appeared, and I'll reset the skeleton to the rest pose and hide the mesh. So now you can see that the red dots are not attaching to the skeleton, they're just floating out in front of it. And that's because the generated mesh with the shape keys and shading has a different number of vertices from the original import mesh here, and a different number from the original Blender mesh as well, which is what the vertices in the config file are referencing. So I did already try to reindex the surface tool generated mesh by finding the unique indexes and saving the corresponding ones in order using the dictionary, like I did for the import. However, that didn't work either. As you can see, they still don't line up. So I'll need to get the position from the original indexed array and then match that with the generated mesh instead. So I'll make a new 3D scene to index the vertices. And I'll save that in the build skeleton folder. Then I'll drag the original import mesh and the generated mesh with the shape keys and shading. And I'll rename these nodes to import and shaded. And I'll set the surface material as well. This isn't actually necessary for it to work, it just makes it look a little better. Then I'll attach a built-in script to the scene, and I need to get the vertex array from the mesh surface arrays for both the import and shaded mesh. So I'll rename those. And now I need to get the unique coordinates from the import array and then match those in order to the ones from the shaded mesh. So instead of setting it to v, I'll set the unique vertices at the coordinates to an empty array, and then I'll loop over so this should be for the import vertices, and then I'll get the indexes from the shaded vertices dot size, and I'll get the new chords from the shaded vertice, and then I'll append the index to the unique vertices at chords, which will be set to an empty array no matter what. And if it's not, then I know this coordinates wasn't in the original array. And then I'll add a new variable for the b to g index equals an empty array, and I'll copy the save JSON function from this forum. So I'll change this to save JSON, take a file path and some data, set the string to file path, and now I can fix the indentions and call the save JSON with I'll want to save it in the same folder. Named b2g index.json, and pass the array as well. And now if I run the local scene and close it, you can see that it's generated the index array mapping the Blender arrays to the surface tool generated mesh. So now I need to open up the skeleton builder scene again, and I'll set the b2g index equal to read JSON. read JSON using the function we added to get the index file, and you can actually set the mixamo config here too, so I can get rid of the ready function. And now when you loop over the vertex indices, I'll change that to Blender index, and then I'll make a new variable for the godot index equals the Blender to godot index at the Blender index, and just get the first element since this is a multi-array, and then I'll get the position at the godot index instead of the Blender index from the mesh arrays. Now I'll need to reload this because I added the variables, and now if I refresh and hide the mesh, you can see that the dots are lined up along the spine and at the neck and shoulders, which is exactly what we wanted. So this is very good. Next, I need to add the dots at the cubic bone indexes. So it gives me a cube name, which is a joint and then a string name with L or R to indicate left or right. So in Blender, if you just make a new human from scratch and then remove the hide helpers modifier, then go to the data, which is the green triangle, and press tab to switch to edit mode, or just change it up here. And then select all the vertices using A, and then on the joint cubes, which is at the top of the vertex groups, you can hit deselect and then push delete to get rid of the rest of the vertices. So now you can see the joint cubes that they're referring to. They have them up the spine and on the hands and toes, although the default rig doesn't use toes, but there are some that do. And if you scroll down, each joint is also in the vertex groups, so you can go through and highlight them to see where each joint cube is. I was able to find the file with the vertex groups configuration. So from the home directory, .config, Blender, and then the version, scripts, add-ons, MPFB, data, and then in mesh metadata, there is a base mesh vertex groups.json, and this has all of the vertex groups that you can select in Blender. So the first couple are the left and right side, so they're really big obviously, and each of these brackets has a start and end vertex, so that includes all of the vertices in the range for each of those, so that's quite a few. But if you scroll all the way down to the bottom, you can see the helpers, and then the joints are here as well. And each of the joints only has one element, and you can see if you subtract them, they all have 8 vertices within the range, which is what we expected since they're cubes. So I'll go ahead and copy the JSON to my project folder. And in Skeleton Builder, I'll load the vertex groups as well and change the name of the file. So now we have that available, and I'll reload the skeleton scene. Then when we check if the bone strategy is cube, you want to get the cube name from the head. So I'll make a new variable equals bone data dot head dot cube name, and I'll print the cube name and refresh. So that's working. And then I want to get the corresponding vertex groups from the cube name. So cube data equals vertex groups at cube name, and I'll print the cube data. So you can see that there's a bunch of arrays. They are nested, so, and it looks like they all have only 2 elements, so I'll just assume that's always true and set the cube data to index 0. So now we have just the array with the start and end of the vertex group. Now we'll pretty much want to calculate the bone position the same way as I did for the mean. So I'll take an array of indexes and add them to the bone position and then divide by the array size. So I'll copy this and make a new function to calculate the bone position, and it'll take an index array of type array, and I'll paste that. So the bone position is 0 to start, and then I want to iterate over the index array. So I'll move that back up, and then you get the godot index and add the vertex position to the bone position, and then we'll divide by the index array size and return the bone position. Now I just want to make sure that still works. So I'll call calculate bone position and set the bone position equal to that. And now I'll refresh it just to make sure that it's still working. Then to calculate the cube position, I'll make a new variable for the index array equals an empty array, and then for I in range, cube data at 0 to cube data at 1. So the first parameter is inclusive, but the second parameter is exclusive. So you'll need to add 1 to that. And then I'll append the index to the index array. And then I'll set bone position equal to calculate bone position from the index array. So now I want to move the bone position declaration above the if statement and just set it to 0. And I'll move the red dot to the end so it works for both of them now. And save that. So now if I refresh, you can see that it pretty much covers all of the joints on the skeleton. So that seems to be pretty accurate. Of course, if I change the blend shapes, the dots don't move, so now I need to calculate the blend shape. But first I want to add some config to make it easier to test. So I'm not sure how to get the changed signal from the shape keys, and also they don't blend together automatically. You have to set the ratios so that it looks any sort of reasonable. If you just turn them all up, you can see it gets very deformed. So I want to restrict that so I don't have to set them all back to 0 constantly. So I'll change the update flag to gender, and I do want to actually set the value. Now I want to get the shape key ID, so I'll make a new variable for the human mesh first, which is on ready, so it'll be done loading, and then I don't have to type that out anymore. So in the gender function, I'll make a new variable for the male shape key ID equals human mesh dot find blend shape by name, and then I'll just use the Caucasian male young shape key, and I'll get the ID for the female as well. And I'll need to reload the scene because I added a new onReady variable. So then I'll check if gender equals true, set the male shape key value equal to 1 and the female value equal to 0. Otherwise, set male to 0 and female to 1. Now if I toggle the gender, it changes from male to female. Then I want to add an age slider, so I'll add a new export variable of type range between 0 and 1 and set it to a float. Then I'll override the set value, so this is called anytime the slider is changed, and I'll set the age equal to the value and call the update function. So now you can see I have a slider and I can slide it between 0 and 1 Now if I navigate back to my Blender plugins folder, scripts, add-ons, MPFB, data, targets, macro details, there's a macro.json here, and it has the string label and corresponding value range for several of the phenotype values. So I'll just copy the age array and make a new array in Godot. Now I'll make a new variable for the age map equals a dictionary. So I'll set the baby equal to -0.01, the child equal to .187, then young to 0.5, and old to 1.01. And I can get rid of the rest of that. And actually I want to make a new function to get the age range. So I don't have to use a break function. I can just return when I find the correct range. So then I'll make a low age and high age variables equal to empty string, and I'll iterate over the age names in the age map and check if the value is less than the age map at age name. So if the value was 0.3, it would check baby and see that 0.3 is greater, and then it would check child and see that 0.3 is greater, and then it would check young and see that 0.3 is lower. So we know that it will be between child and young. So if the value is less than, set the high age equal to the age name. Otherwise, set the low age equal to the age name. So this will be set to the previous. And once it finds the correct age, because it will also be less than old, you'll want to return both values here. So I'll just make a new dictionary, set low equal to low age, and high equal to high age. This way you don't have to make a whole new class, you can just have the variable names like that. Then in the setAge function, I'll get the age range variable equals getAgeRange from the age value, and I'll print age range just for now, and I don't need to call update since we don't need to be recalculating those. So now I'll reload the skeleton builder, and now when I change the slider, you can see that it's printing low child, high young, until we get to 0.5, and now the low is young and the high is old, all the way to the end. And then when it gets below 0.18, it changes from child to baby. So that's working. Now I need to get the low and high age shapekey IDs so that I can set them on the mesh. So in the setAge function, I'll make a new variable for the low shapekey ID, and instead of -young, I'll append the age range .low string to the shapekey name, and for the high age shapekey, I'll append the high value. And now I'll just set it to 50% on both. Just to demonstrate. So now if I change the age slider, you can see that as it gets younger, it adds the shape keys. So I also need to clear the previous shape keys, and then this will work because all of the ages are now set to 0.5. So I'll make a new function to reset the shape keys. And then I'll loop over the human mesh get blend shape count. So for I in blend shape count, and then I'll set the blend shape value at the index to 0 for all of them. So this will set it back to the basis. And then when I set the age, I'll call the reset shape keys function. So now you can see here is the young to old, and the child to young, and the baby to child, and those now look much more correct. So now I just need to get the actual ratio between the high and low. So in the script, when I get the age range, I'll make a new variable for the total, which will be the age map at the high age minus the age map at the low age. So this will be 0.18 minus 0.01 or 0.5 minus 0.18 to get the total difference. And then I'll get the difference value, which is equal to value minus age map at low age. And I'll get the ratio cast as a float, just to be sure. and I'll divide the difference by the total. And then I'll add the ratio value to the dictionary when I return. So now when I set the blend shape value, I can set the value to age range dot ratio and 1 minus age range dot ratio. So now when I change the slider, so that's almost working. You can see the transitions are reversed. So I need to set the high age to the ratio and the low age to 1 minus the ratio and save it. And now when I change the age, you can see that it smoothly transitions from baby to child to young and old. Now I need to take into consideration the gender as well, so I'll fix that. In the script, I'll combine the set gender and set age functions in the update blend shapes function, and I'll call this in both places. So I need to reset the shape keys first, and then I'll get a gender string equals female, and if the gender equals true, set the gender string to male. So now I need to get the age range. And instead of setting male here, I'll insert the gender string into the shape key name. And I want to add it to the high ID as well. So now I have both of the shape keys selected, and then you'll just set the blend shapes like we did before, and I can get rid of all of that. So now if I toggle the gender, you can see it changes from male to female, and it keeps the age. So next I need to calculate the bone positions from the shape keys. Now that I have a working character creator, first I'll make a new onReady variable for the blend shape data equals human mesh dot surface get blend shape arrays on surface 0, and I'll be using the vertex array So from the mesh arrays at mesh.vertex, and then I can copy the vertex array down to the bone calculation here instead of calling the vertex index. So then I want to rename the update function to build skeleton, and I'll make a new update function to call the update blend shapes and build skeleton functions, and then I'll just call update in the set gender and age, and I'll need to reload the skeleton builder scene so that all of these onReady variables are set. Then I'll make a new function to get the blended vertex position from the godot index. And first I want to get the initial chords from the vertex array at the godot index. And I'll make a variable for the change amount equals vector3.0. Now I want to loop over all of the shape keys in the human mesh get shape count, and I'll get the blend shape value from the human mesh get blend shape value at the blend shape index. So that will just get the float value at the ID, which will be between 1 and 0, or -1 and 0. Now I want to make sure the blend shape value does not equal 0. Then I'll get the actual coordinates of the blend shape from the blend shape array. So I'll get the blend shapes, and this has an array for each blend shape, so I need to get the blend shape index, and then it's in the format of the mesh arrays, so it has 11 indexes and only the vertex, tangent, and normals are set. So I'll get the mesh.vertex array, and then I want to get the godot index from there. So this will be the coordinates of the shape key, and I want to make sure that the blend shape chords don't equal the initial chords. Then I'll make a new variable for the difference equals the blend shape chords minus the coordinates, and then I'll multiply the difference by the blend shape value, and add it to the change amount. And then at the end, I'll add the total change amount to the coordinates and return the chords. And then in the calculate bone position, instead of calling the vertex array, I'll set bone position equal to get blended vertex position at the godot index. And I forgot to mention that you have to get the difference between the initial chords and the blend shape, because the mesh has the blend shape mode set to normalized. So these are absolute coordinates. If the blend shape mode was set to relative, then you wouldn't have to find the difference. You would just multiply the blend shape chords by the blend shape value. So now if I change the slider, you can see that the dots are following the shape keys, but it's keeping all of the previous ones, which makes kind of a cool effect, but I'll need to clear the red dots between updates. So I could just iterate over each dot and queue free it, but I think it'll be more efficient if I just remove the red dots node and make a new one. So I'll make a new variable for dots holder set to a new node 3D, and then I want to set the node name to red dots so we can still refer to it here, and then I'll add it as a child of the scene. And save it. So now when I change the age, only the current set of dots are on the skeleton, and as you can see, it follows the shape keys. So now all I need to do is make the bones line up with the dots. First, I tried to build the skeleton directly from the config without using the exported one. So I'll add a new Skeleton3D node and move it over. Then in the script, I'll want to clear the bones on the Skeleton3D first, and then whenever I get the bone name, I'll add it to the skeleton. Add bone, bone name. And now if I update that, you can see it throws an error, and the problem is that the name contains a semicolon. So you can see in the rig.mixamo.json that the bone names and the bone parents do have a semicolon or a regular colon, but in the exported skeleton, the bone names have underscores, so that's why those changed, and I'll need to parse the config file basically when I load it to replace all of the colons with underscores. So I'll make a new function to load the mixamo config. I'll set the in data equal to the rig mixamo JSON, and I'll set the mixamo config variable equal to the function. Now I only am using the bones value. There are a couple other variables here, but they're not really necessary. So I can specify the bones index, and that will simplify everything. And then I'll get rid of the .bones later in the code. So then I'll set the out data equal to an empty dictionary. and I'll loop over the bone names from the in data, set the out name equal to the in name dot replace colon with underscore. Then I need to change the parent name as well, so replace the colon. So I'll get the parent name equals the in data at in name dot parent, and I'll replace the colon with an underscore again. So now I'll set out data at out name equal to in data at in name, and finally I'll set the out data dot parent equal to the parent name and return the out data. So now if I'll need to reload the scene because I changed the variable declaration. But so you can see that still works, and in the Skeleton3D, now the bones have been added to the skeleton, but they're all in a list. There's no hierarchy. So if you look at the imported skeleton, it's a tree structure, and there's only one at the root, the hips, and then all of the other bones are attached to that. So I'll need to set the bone parent when I add them. But first I want to put the bone position into its own function, so I'll rename calculate bone position to average bone vertex. And then I'll make the calculate bone position function, which will take the bone name and I'll copy all of this and the bone data into the function and return the bone position. Then in build skeleton, I can set the bone position equal to calculate bone position from the bone name. So I'll save that and just make sure that it still works. Okay. And now I can set the parent ID for the generated skeleton. Now I do still need the bone data, so I'll copy that back to the build skeleton, and now I'll get the bone ID equal to skeleton.findBone at bone name, and I'll get the parent bone ID equal to skeleton find bone at the bone data dot parent, and then you'll want to set the bone parent with the bone ID and the parent ID. So now if I update this, in the generated skeleton, you can now see that some of the bones are in the tree and they have their parent set, but some of them are not. So we have multiple bones at the root, and there should only be the hips. And that's because as you iterate over the file, sometimes the parent hasn't been added yet in the file, so when you try to get the parent ID, it doesn't exist yet. So I'll have to do this in a second iteration over the bone names. So I'll make a new for loop to add the bones, and then set the parents in the second iteration of the config, and I'll update that. And now you can see that all of the bones have been added to their parent. So now if I set the bone position equal to the bone position that I calculated, skeleton set bone position at the bone ID to the position, and when I update, you can see that it has placed the bones and built a skeleton, but the coordinates are global from the function, but they need to be converted into relative coordinates because each bone gets its position from the parent. So to get the relative position from a global position, you used to use the transform inverse function. So, but now you can just multiply the vector by the transform. So first I'll need to get the parent transform. So equals skeleton dot get bone pose get global pose, and this will return a transform 3D, and we want the parent ID, and I'll just print the transform for now. So you can see some of the parents are set, but a lot of them are just the 0, the identity transform. And that's because the JSON is out of order and it's setting the child bone position before the parent. So I'll just need to use recursion to add the bones and then loop through the skeleton node instead. So instead of calling skeleton add bone in the build skeleton, I'll make a new function to add the bone name, and it'll take the bone name as the parameter. So we'll still add the bone if the conditions are met. First, I want to make sure that the bone name is not already in the skeleton. So I'll use find bone with the bone name and make sure that it's not equal to -1, so the index is already set. Then just return. Otherwise, I'll get the bone data from the mixamo config at the bone name, and I'll get the parent name from the bone data.parent, and if the parent name does not equal an empty string, which this is just for the hips, every other bone has a parent name, then you'll call add bone name with the parent name. And finally, I'll call skeleton add bone. So now if you look at the generated skeleton bones, you can see the left leg and then right leg and then spine are here. But now if I update this, you can see that it's added the head first because that's the first bone in the file, and it added all of the parent bones in front of it. So now these are actually in order. Now instead of looping over the mixamo config, I'll get the bone ID in the skeleton bone count, and instead of the bone ID, I'll get the bone name equals skeleton dot get bone name at bone ID. So now if I clear this and refresh, you can see that all of the parent transforms have the position set, except for the first one, which is the hips, but that's fine. So now I need to make these coordinates relative to the skeleton. So I'll move the bone position up and check if the bone data.parent does not equal empty quotes. Then get the parent ID and the parent transform. And like I said, you can just multiply the vector by the global transform to get the relative coordinates now. So I'll set the bone position equal to bone position times parent transform. And now, when I update, you can see that the skeleton is now matching to the mesh. As I make it grow older, the skeleton gets larger, and if I change it to female, it gets thinner. So now I just need to move the mesh onto the skeleton, and the red dots are pretty much useless now since it's relative, but I could move this up to before it applies the parent transform. and those will still work. Now I can move the mesh under the generated skeleton and reset the transform, and then move it back, but keep the transform so the onReady variables can still get the mesh arrays, but it's over here. And now I can still change the slider and the gender, and you can see that the mesh matches up with the skeleton perfectly. Even all the little finger bones are within the mesh. However, when you assign the mesh to the generated skeleton, this is what it does. So I need to basically, because the bone weights are mapped to the import skeleton IDs still, and it generated the array in a different order still, and I'm not sure how to derive their imported order other than just looping over the original skeleton. So I'll just do that, and so instead of the generated skeleton, I'll use the human rig skeleton and get the bone name. Now, since these are in order, I can add the bone name from here. Since I know the parents will have a lower ID, so I can get rid of this. And now if I change it, you can see that the human is a lot more recognizable now. It's still very deformed and nightmare fuel, but this is definitely a step in the right direction. So this is caused because the generated skeleton doesn't have a rest position. When you use the animation player, it changes the bone positions, but you can still select the skeleton and reset the bone poses to get the default position. But with the generated skeleton, if you reset the bone poses, it just disappears. So in the script, when I set the bone pose position in build skeleton, I also need to set the bone rest pose. So I need to get the bone ID, and so this is just the position. I also need the rotation and scale for the transform, so I'll get the Skeleton3D get bone pose at the bone ID. Now if I save and update, you can see that it doesn't look like it's working, but if you reload it, now the human is lined up with the skeleton, and if I change the sliders, you can see that the skeleton still doesn't line up, but it's a lot closer than it was before. This is easy enough to fix by going to the human mesh and resetting the skin. So you can see it lines up now. And in the code, I can use the, once it's done building the skeleton, set the human mesh dot skin equals to the Skeleton3D dot create skin from rest transforms. So you could set it to null, but I think this is probably better. So now, when I change the age, you can see that the skeleton is lined up with the mesh, and that seems to be working pretty well. And you can change the bone rotations. So I can kick the leg forward, and you can see the mesh is still aligned with the skeleton, which is good. You can wave the arm as well. So the only problem is if I move the mesh to the skeleton and delete the original, but not the animation tracks, and move the skeleton back to the human rig, now you can see while it is animated, the bones are obviously not in the right positions, and it looks like a Dark Souls boss. So this is because the animation track is absolute instead of relative, and the bone rotations are all set to 0. So if I put this back, and I can reset the bone pose, so you can see that in the generated skeleton, all of the bone rotations are 0, but in the imported skeleton, they all have a different rotation. And I probably could calculate that from the bone head position and tail position, and then there's a roll value, which is probably the rotation on the axis between the 2 points, but the animation would still be global, so it would be slightly off either way. So I decided to just use the original skeleton and keep the bone rotations so that it will match to the animation the closest. It doesn't set any bone positions except for the hips. The rest are just rotations, so it should be close enough for all of the blend shapes. First, I need to make a new onReady variable for the skeleton from the human rig Skeleton3D. Then I'll replace all of the references to Skeleton3D with the new variable. I do not want to clear the bones anymore since we need to keep the position, and I don't need to add the bone name or set the bone parent either. I also want to get rid of the red dots, and I need to reload because I added a new variable. So now you can see when I change the age slider, the original skeleton is changing, and I can just assign the mesh to the new skeleton to fix it, and then reset the transform of the mesh so that it lines up with the skeleton. And I don't need the generated skeleton at all now. So now you can see the age and gender still works, and it's actually working a lot faster now because it's not printing out all those errors like it was before, because it couldn't find the bones for the skin to attach to before it was done building. Now you can see also the animation player does work with the mesh, and if you reset the skeleton and change the age, you can see that the mesh is not distorted and the limbs are all going in the correct direction. So the animation still looks good. The problem is if you don't reset this and just change the slider, so it looks okay here, but then when you play the animation, you can see that it was using the rotations from the last frame of the animation to generate the new rest positions. So I'll go ahead and reload from before, but I could also just put the blend file back here and reset the skeleton that way. So I could probably calculate the rotation, but I think it'll be easier to just call skeleton.reset bone poses. So this will set it back to the rest position before it calculates the bone positions, and then it will set the rest from that. So it should keep the rotations of all of the bones. So I'll play the animation. You can see everything still looks normal. Now if I change the sliders and play the animation again, you can see that everything still looks right. So the only problem is whenever I turn down the size, the hip position is set up in the air to where the default hip position is, but I'll probably have to use raycasting to get the character on the ground. So, but other than that, I think this works really well. I think it looks really good, and I'm very pleased with the results. So I will add the clothes and the hair and all that at some point, but I'm probably going to take a break for a while. So that's all for now. Thank you for watching and have a great day.